Hello, what's going on everybody? My name is Özkan. I'm a vulnerability researcher. I have a research to present to you today. The title of my research is Remote Code Execution via Meow Variant along with an example zero day. So let's take a brief look at the presentation schedule. I'm going to talk about what Bash is without dwelling too much on it and show you the structure that I defined as two-tier. And then I'm gonna touch some alternative bypass restrictions techniques. Later on, I'm gonna present a vulnerability of Ericsson network location that provides the infrastructure of the research. I'm gonna touch on the Meow variant with details throughout this vulnerability. Towards the end, we're gonna prepare a Metasploit module and exploit the vulnerability. Let's start without wasting too much time. So, what is Bash? Bash is the shell, a common language interpreter for the Juni operating system. The name is acronym for the Born Again shell, a Python Stephen Born, the author of direct ancestor of the current Unix shell SH, which appeared in the 7th edition Bell Labs research version of Unix. Bash is largely compatible with SH and incorporates useful features from the Corn shell KSH and the C shell CSH. It offers functional improvement over SH for interactive and programming use, while the Juni operating system provides the other shells, including a version of CSH. Bash is the default shell, guys. Like other Juni software, Bash is quite portable. It currently runs on nearly every version of Unix and a few other operating systems also. There are different types of shells available in Unix operation systems, but the Bash has been around for over 30 years. Because of its long service life and massive user base, Bash is mature and very stable. Time spent figuring out what incantation should be on a new other shell is that time. So it's in interest of the client business to use a well-known and widely used shell. That's why everyone is easier to use and familiar with the Bash shell that comes by default for Linux. We took a quick look at Bash, so we already know how many commands there are on the shell. If there is a mechanism that prevents what we want to do, we can use these commands in combination each other. A hacker always wants to do a single line operation on Bash, and this can be broken some characters, or there may be restrictions on the command line that are belonging us. At this point, it can take advantage of Bash's own features. It will demonstrate this with example. Let's talk about restrictions. In the platform that are tried to be hacked, there is usually a tier that tries to prevent attack you will make. So the number of this tier can be more than one. There may be a firewall blocking the attack, protocol-based restrictions, or filtering function in the source code waiting for the surprise you. I am assuming the first tier is all of these. The second tier starts after reaching the shell, guys. A vulnerability you discover for running commands on the server indicates that you have bypassed the first tier. The real challenge starts when you want to be comfortable on the server, because the attack payload you will use at this point should bypass a two-tier restriction. We can imagine that there is a gate in all places where payload passes, so the attacker has to find a way to get throughout these gates. By bypassing throughout these gates, the attacker must also mature the payloads and try to achieve its ultimate goal. There are some bypass restrictions, techniques, and variants that can be used to be successful. One of them is a variant. I name it, and I'm gonna present it to you today. Let's take a look at this with a few examples. For example, let's say we find a command injection vulnerability on a web application. The source code may have filtered some words in the background, or you may be running command on rbash. You know, rbash mean is restrictions bash already. Let's say where my ping and or other is some command you want to use are restricted. We can use some substitute characters that have a binary equivalent. In software, a wildcard character is kind of placeholder presented by a single characters, such as an asterisk, which can be interpreted as a number of literal characters or an empty string. So we can take advantage of this situation. As you can, our examples, we can see that we can get possible results. Also, we can use question mark and quiz too. If there are restricted characters like forward slash or something, the check command also can be very useful at this point. So it's used to be transform string of delayed characters for the string. Various type of transformation can be done by using this command also. So we took some of these techniques for command execution against restrictions. Today we will use some of these again to exploit our vulnerability. So time to review vulnerability. Ericsson, the network location, is new model location platform built to answer the needs of vital location use cases. I had the opportunity to research such a platform. I wouldn't have had such a chance otherwise if I'm not working at ISP company. Ericsson network location has a nice web interface. It has functions that allows you to control mobile and reference networks, positioning and method control, cell data, and some components. Overall, Ericsson NL is the mobile positioning system. It's also the global navigation satellite system related configuration. So where is the vulnerability? There are export and import functions in some part of application. A function that allows you to export data to the server, then import again if it's necessary. During this process, you can specify the file name yourself. In other words, a file is created on the server with the file name you specify. The vulnerability is exactly in the file name variable. This process is performed by Java located in the infrastructure of the application. And let's perform a simple example of what might happen in the background. And let's create a file with any content on bash. We can manipulate file name variable. Therefore, we can inject a different command into such a command. We turn off quotes and create a new command file with the pipe in this payload. Then we need to end this area with the pipe again, because there is a command set in the background that continues after the file name variable. We print the result of the command in what to run the file, such as ifconfig maybe, because the HTTP response does not show the result of the bash line. Therefore, we will test the result of the injected command by reading the content of the file we print to the server. Our simple example turned out to be positive. So now, with this logic, let's send a request to the server with Bobsy. And of course, our characters must be URL encoded to pass throughout the HTTP protocol easily. So after our payload is ready, we can send it to the server. As can be seen in the response, it can be understood that something went wrong. Let's check a background. We have an SSH connection to the server, therefore we can check from here whether the file has been created or not. As you can see, the command injection was successful. We will perform our next transaction using this payload. Also, in addition, when we examine the log files of the application, we have SSH connection. We can check all log files in here. And when we examine the log files of the application by sending the payload back to the server, we can see that the file name parameter belongs to the actual file name variable, guys. It's actually here's the main source of the vulnerability. Also, we can see the other logs in this file, and we can follow everything here. So now we are able to inject command on the bash. We need to check if there are any restricted characters. So I'm gonna start by trying to create something with echo. First, I need to change iconfig instead of echo. We can write anything, test or something, it doesn't matter. And after send this payload, we can check our server. As you can see, the file was not created. This means that space is restricted for us. Also, many other characters are restricted too. But first, we need to find a solution to space. This is so important because we cannot do many operations without space, guys. At this point, I will have a solution for this. I'm gonna use internal file separator. It's IFS. The IFS is a special shell variable. You can change the value of IFS as a per your requirement, so we can use the space by defining it to IFS. Let's check how we can do that. In the IFS syntax, we must define the command dot side by side to correspond to the space. This means the space will reflect every time we define the IFS. So let's try it's work, as you can see. Now let's test this on our target. Also, the characters must be well encoded. Let me copy. I have this palette also. It's okay, yes. After sending, let's check the server. This technique works successfully, guys. We are free of these restrictions. We can use IFS for our space restrictions. Now let's focus on other restricted characters. For example, let's try to read to etc passwd file. As you can see, the operation couldn't be completed. This is because / is restricted. If we remove the /, the process will be completed. So, what can we do at this point? We cannot use IFS because IFS is defined for space. First, we can try to print the / into a file by taking it alone. How about using XXT? XXT creates a hexdump of a given file or standard input. It can also convert a hexdump back to its original binary form. So we can print a / with echo by taking the hex value of the /. Let's try it our own bash. So it's worked successfully. Let's try in our target too. I need to copy the payload. Now, as you can see, our payload is ready, and we are sending it this server. And let's check. Yeah, it's was successful on target too. When we try again with another character, our payload, we can see that is successful again. Guys, what about a large payload? Can we print a larger payload to get a reversal with the existing? So let's try it. We can send the large payload to the server for check if it's possible or not. I converted some payload to hex, and I'm sending it to the server right now. And as you can see, it's not possible because many characters in the payloads are also restricted. In this case, we'll have to use the restricted characters alone. If you can imagine it, it's turned into a puzzle actually. To solve this puzzle, we must resort to a new variant. Let me explain what is Meow Variant. First of all, let's try to read the PHV file again to explain what the Meow Variant is. We realize that we cannot use restricted characters together. Therefore, we need to call these characters with a different variant. The restricted character / is required for us to print the PHV file. We have already written / in the file before. So let's do this again and specify single-digit file name. For example, let's name of the file be y. Now there's a / in the file name y, so we can call the / character with the cat command, and we can embed it inside the echo command. Let's test in our own bash. There should be file name the y, so we can test it. It works successfully. Time to try on this on our target. It passed here. So we have to print it with a different file name. So let's send it to the server. No. Yeah, wonderful. We can read the PHV file by trying again with the cat command instead of echo. Let's try this too. Need to change echo to cat. So we get a positive result again. So how should we process next? We must define all restricted characters with a single-digit file names and print them to the server. After this process, we can use all restricted characters by calling them with the cat command, just like we tried to read the PHV file a moment ago. There might be some confusion, but let me show you how to put puzzle pieces together, guys. If you remember, we couldn't print large payload because of restricted characters. Well, can we succeed in printing this large payload if we call all restricted characters in the payload with the operation with it /? Yes, it's definitely possible. But HTTP request, we are using the command injection process as get method. With the get method, it's impossible for us to transmit this payload, which will contain a lot of cat and RFS. HTTP will not accept this / of request. So we have to print the payload, dividing it into parts. I will use bind shell because I'm prevented from opening TCP ports in my network. We can use netget bind shell. Let me create it with MSF panel. So it will be enough to split this netcat payload into two parts. Let me show you the action we want to take on our target in my own bash. After creating the payload with MSF Venom, let's divide the payload into two parts in the printed. With cat, we combine these two parts into different parts of the shell file. So payload 1 and payload 2 is our files to combine these commands. So change mode to sh1 file. So we can get the IO reverse shell by running this file. Our method is perfectly structurable for testing on our target. However, in order to print this divided payload to the server, the restricted characters must first have their equivalents on the server. Let's get rid of this problem first, guys. As a result of my research, I discovered that the characters you see on the screen are restricted. You also see the hex values. And we need to call some values from a single file to shorten the payload. I noticed that the sum of the characters next to each other breaks the syntax when they are called separately. Therefore, we will print the characters ampersand and / at the separate entities, which break the syntax when placed after angel bracket. You can also see the payload prepared for the / this payload must be sent to the server one by one for all characters, guys. Time to prepare a basic MSF exploit. It will be very sensible. By sending all payloads quickly, we will completely get rid of the restricted characters plan. You are seeing a demo exploit that I have prepared in order not to waste the time. You are seeing a demo exploit that I have prepared in order not to waste time. We're gonna use the HTTP client library. The definition initialize will allow us to control some information about exploit. For example, the description and author and license references and privilege, exploit is privileged or not, and the payload details, and there's a default options here. You know, you have the bind netcat shell we're gonna use, and we are set this payload here, and there's another information platforms or targets, and we have one target already, and there's the register options, and we just need the token to send our request to the server. And we have a definition pair here. We're gonna use this pair on our origin header to use on HTTP protocol, and we have definition prep payloads. We are seeing that is our restricted characters, and we have payloads to send the server by one by. We need to create the restricted characters files on the server, and I choose to use JSON, and they have a number to send the server this with a while function, and in this function the pipe parameter we are using, and in this while function after the process we are sending the definition send payloads in these payloads, and then our first process is finishing here, guys. This is our basic Metasploit exploit. I need to explain why I don't use shell data export in the exploit, because as you can see we use the exploit operation in the poisoning controls area, The reason for this is that we cannot perform the export operation one after another in the cell data area. Let me show this. Yeah, as you can see, the server is reflecting the error. Don't execute more than one important export. In fact, we can resolve this problem with the sleep command in the exploit, but the exploit works very slowly. In the positioning control area, it reflects the HTTP 400 response, but the command injection is successfully working. And we can send this request one after another friendly. As you can see, it's worked very nice. So using the cell data area should be a last solution for exploit. Now it's time to run a basic exploit and check what happens on the server, guys. I am already have a Metasploit in here. I set all information to our exploit. Let's run. And let's check what's going on the server. As you can see, the payloads we have sent for all restricted characters has been successfully created. As you can see, when we check inside town, we see that there is no any problem. Now we can do the necessary actions to get reverse shell that we got rid of the restriction characters problem, guys. So at this point we cannot use Metasploit functions payload encoded because we should send payloads manually. Then we will split this payload into parts as we tested before. First, let's create a payload with MSF1 quickly. CMD units bind to netcat port 10,000 maybe. Let's put the payload into exploit as a node and let's analyze what should come after the 16th payload. We will print the first payload of the payload to the file name P1. We will print the second part of the file name P2. And then we will combine the P1 and P2 files with the cat command and print them to a file named 1.sh to run our payload. But before run, we should give permission to 1.sh file, of course. So there are 5 more payloads we want to send. In total, we will send 21 payloads, one after another. I'm copying these payloads that I have prepared before from my side screen. In the payload, we obtained information, the data store variable from Metasploit. Also, a variable called FIFO that can generate a 4-digit random alpha lower text has been inserted. To temp file is different each time in our payload. Let me copy the past payloads. I need to pay attention to correct order. Also, let's get their nodes and so they cannot get mixed up. It's okay. For the while loop, Also we need to change it as 21 because we have total 21 payload right now. I need to fix these knots first. And here one is I should be here. Yeah, payloads are ready, and time to change the while loop number. Yeah, 21. It's okay. So finally the exploit is ready. Let's run it. Yeah, it's worked perfectly. Let's check what happened on the server right now. Our restricted characters are here. .sh is here, and the P1 and P2 files were also written and run successfully. As a result, we have obtained an exploit with all the operations we have performed. Let me show you a different exploit. In addition, the privilege escalation is possible throughout this vulnerability. I have prepared a nice Metasploit auxiliary module for this. So let me show you. The lowest authorized user in Ericsson network location is cell data user. Therefore, I will show an example throughout this user authority. As you can see, the user is only allowed to manage cell data. Because of the exploit going to use the cell data export function, but I mentioned the problem here before. Cell data export function prevents us from one after another request, so the exploit will run very slowly. Let's run the exploit. There's also check model too. Let me show you what's going on in the background during the exploit is running, guys. The Ericsson NL uses Postgres. It also has different components too. The configuration file that contains the most important information is under the control of MPC user, and we have this user already when we command injection on the bash. So we can read this configuration file, and name of this configuration file is gmpc-sigma.json. In this way, by obtaining the Postgres information in gmpc sigma.json, we will be able to perform any operation on Postgres and even switch the Unix Postgres user. So, the PostgreSQL, I'm copying this file to our main directory. The Postgres password is located on line 31,843 of this file. At this point, we call this line with the SID command, and we can obtain a sole password with the AWK command also. And we will combine these commands together. Let me paste. As you can see, we succeeded in obtaining the Postgres password. Therefore, we can set this password as the PG password variable in the bash, and we can run SQL commands. As you can see, and after this process, we can insert a new user also. Let me pass this comment also. I have prepared for you before. Let's change the username. It's okay. This is what our exploit does in the background right now, guys. Let's check our new user is available or not. Need to copy the username. PHV-12333. What was this hash value? Let me check in second screen. I find it. Saturday. Saturday. Yeah. Come on, Ericsson. Yeah. As you can see, we have the user admin privilege right now. So, but again, to address the characters, all these payloads have to be split into parts and then combined, just like our RCE exploit. You can see the combined payloads in the exploit after dividing with a sequential logic. So we divide all the payloads with the echo and cat commands and then combine them. And the Meow variant is exactly that, guys. We use a lot of echo and a lot of cat. That's why I named this variant a Meow variant. Let's take a look at what happens to exploit right now. Exploit has been successfully completed and our new user has all privileges. So let's check this user too. And logout. And here's our new user username. This is our default password. Server is a little slowly, guys. I'm sorry. Yes, as you can see, we have a new admin user also here. That's all I want to show you.